writing Dynamic SQL and calling it using the Execute and Execute Sql. We're going to cover what is Dynamic SQL, what is SQL Injection, because that comes into play with Dynamic SQL, and the differences between using the Exec or Execute and Execute Sql. So what is Dynamic SQL? As you can see here, there's a couple slides or a couple examples on here on, you can concatenate text together and then call it. Let's see here, go to this on the little script. I'm going to hop back and forth between the slides and the scripts. So we're going to use the simple create a database, use the inventory table and categories table, fill it with some sample data, and then fill it with a whole bunch of random GUIDs just to kind of blow the tables out a bit. So here's some Dynamic SQL. We can declare the select, put the select into a variable, put the from into a variable. So select 3 columns, and then from the inventory table, and where the quantity on hand is less than, and not put a value on, and we can concatenate on a value that we want to run the query, and then we will use we will concatenate the select, the from, the where, and the user's entered field all into the query variable, and then run exec query. We'll run that. We can see that it put all of the it built the SQL statement dynamically and then called it with the exec. So we can comment out this user entered field 6, setting it to 6 and change it to 3. And now it will build out a SQL statement that returns the inventory fields from the inventory table where the quantity on hand is less than 3. So we'll run that again. We can see that the results changed. So this is a very, very simple way to dynamically build SQL statements, but as we'll see later on, that it's vulnerable to SQL injection and performing malicious attacks on your database if you just blindly accept what a user has entered in and build it into your SQL statement. Here's another slide showing how we can build out a SQL statement on the fly and run it. All right, SQL injection. So what is SQL injection? A lot of us have heard about it, but maybe some people don't really know what it is. SQL injection is kind of changing or adding on to the query that's getting ran and injecting your own custom SQL. So this is using the exec query command, and here's the same SQL statement that we dynamically built before, where we just selecting out 3 columns from the inventory table where the quantity on hand is less than 6, and say 6 is a value that was entered in your web form or some other application form, and it just gets passed straight through to this query builder and just tags it right on. What the user could enter is they could type in 6 and then a semicolon, which means the end of the database statement, and then add on drop space table space inventory, and according to the SQL server, that is 2 different SQL statements there, and it'll run both of them if you don't have permissions nailed down and if you're not protecting the SQL injection. So let's hop over to the first time it's ran. You'll see you'll get the result set back, and then you also get another result set of the table's gone. So let's run that statement there. So we have the select columns, we have the from the table, and we have the quantity on hand, less than 6, or less than the user entered field, which is 6, and we added on a drop table inventory. And here we concatenate all of the variables together to build our SQL statement. And we can run it. See, it works fine. You know, the user's none the wiser until someone goes and tries to run a query against the inventory table and it has been dropped. So that's a real easy way to mess somebody's database up, is to perform SQL injection attacks on them.
So if that wasn't at the end, like they had some more and in their where clause or order bys, would it get a syntax error and not do the drop?
So the question was if this field was in the middle of multiple filters, multiple where clause, so quantity on hand is less than 6, and then an and category equals something else, would it get a syntax error? And yes, it would get a syntax error, but the user might see that syntax error and just move it around and find which parameter is added on last in the statement that's getting built. And, you know, then your tables are gone.
Isn't there a way to do a comment that would make everything else before it?
Oh yeah, do a dash dash at the end,
Yeah.
right? And do a
So
semicolon at the end of your drop.
So yeah, so the question was, can you add a dash dash and comment out the remaining code? And yeah, you can also do that. You know, put a dash dash in there, and it will comment everything out. Or if multiple fields, you could put in the / asterisk in one field and a / in the other field, and it would comment out everything in between. So using exec is not really a good idea if you don't have control over what's getting passed in. There's other reasons why it's not a good idea, which we'll cover later on. But now our table is gone, so we need to go back up and recreate it.
Another question before you do that. The exec allows for any block of T-SQL to be ran, I assume?
Yes.
That has permission. So could it run its own dynamic SQL in it?
That's the question was, does exec run any block of SQL inside of it? And could you nest execs? And yes, you can.
Too late to do recursion.
So now we'll get on to exec. I'm sure we've all seen it with calling store procedures, and that's fine. We're passing parameters into store procedures. There's no SQL injection that's possible when you're calling a store procedure. Inside of your store procedure, you could dynamically build statements and have SQL injection inside, but you can't kind of hijack the calling of a store procedure and have it perform some other actions. So yeah, with exec and store procedures, parameters, or you can parameterize store procedures, but you can't parameterize the SQL statement that you're calling within the exec. Like the SQL injection sample that I showed, there's no way to parameterize that using this exec function. You have to use a function or a calling thing later on that we'll cover. Another thing about using the exec is it doesn't use the query plan cache, or when it does, it doesn't parameterize the statement inside. So every time you change the parameter, you're going to get another plan inside. If you call that the same SQL that you built, the ad hoc, they're stored in the query plan cache as ad hoc. They're not stored as prepared. So if you call that exact same statement with that exact set of parameters, hard-coded parameters again, it will reuse that same plan. But odds are you're going to be changing the parameters. Sorry, not changing the parameters, but changing what you're querying on, and that's going to create a whole new query plan. All right, so let's go. It's using exec. So let's create a store procedure. It just returns the top one row from the inventory table. And we can see we use exec here. And that executes the store procedure, which there's no parameter. For this store procedure, we're not passing in any parameters. And we can get, let's see, make this bigger. We get the result set back, which is just to select top one from the table. So when you are creating a store procedure with the parameter, here's the syntax for that. Create procedure, name the parameter, and you pass the parameter in. Create that one. And this is how you call it. You can set variable. You can put a hard-coded value in there if you want. But this sample just shows that you can use exec with the parameter when you're calling a store procedure. And we get back all the inventory records with the category title of food.
So if you run that without the execute exec on it,
Mm-hmm.
is that just SQL Server Management Studio adding an exec under the covers kind of thing?
So the question was, if you remove the execute and run it, yeah, you can see.
Yeah. How'd that work?
I
Well,
think you have to like
say,
quote some.
it's gotta be a standalone.
Yeah,
You know?
so you can remove exec if you if you have a hard-coded value.
Quotes,
Yeah, you can run it. So I don't. It's the server side will take it, add the. It knows you're executing a store procedure, and it will add that on there for you. Right. So
Would it function that way too?
The
I don't
same,
think so.
yeah,
same rules would probably apply then, right?
for
Injection and all that.
yeah, but you're
Caching and
calling
all
a
that
store.
stuff.
Yeah, it's the exact same as calling a store procedure. So all right. So now let's compare store procedures versus the execute concatenation. First, there's two statements I ran: dbcc free procedure cache and free session cache. Clear out all the query plans that have been stored right now. It's not something you want to do on live or anywhere that you care about performance, because that means every query that gets ran after that will there will be additional performance when you hit when you run to go out and create all the plans again. All right, so we're going to use our table. Going to build our select star query again. We will run it with the exec doing the ad hoc, and then we will run the store procedure, which return the same or use the same query as our ad hoc one, returning the food category. So we can see the results are the same. And then this query here is a select from the syscache objects table, and that will show us the query plans, the cache plans. We can see that, and there's some other ones in here, but these are the two that we want to look at. This one is the store procedure, this row. We have compiled plan, procedure, the database name, and procedure. So it actually creates a plan for the store procedure. And then the one above it is a compiled plan, ad hoc type, and it's just the select star from categories, where category title is food, so it's hard coded right there. It's not a parameter. And we can run those again. Run them a few times. Oop. And a whole bunch of times, so let's check it again. And we can see that we have use counts of 8. It incremented the use count for each of those plans. All right, so let's now we'll look at.
So that just tells us that it recognizes them as the same.
Yeah, the question was the use count tells us that the query optimizer recognized the query that was going to get ran, matched one already in the plan cache, and yes it does. So we're going to use exec again, and we're going to run this dynamically built statement. The first one we did, select the 3 columns from inventory where the quantity on hand is less than a given value. And first we're going to run it with a user entered field value of 6, and then we're going to run it again with the user entered field of value of 3. So we'll concatenate on the 6 and run it, and then we will clear the query and run it again with the value of 3. So double check that we cleared that, and then run these. No, when so that was when you look at the system cache objects need to be in the master database. So I was over in the master database. So we'll run that, and we see the 2 different result sets. Now we look at the plans. We can see that right here, these 2 rows show that even though it was pretty much the same query, and we only changed one value we were filtering on, it created 2 different plans in the database. So if you have 50 different users running the same dynamically built statement that's not parameterized with the exec, you're going to get 50 different. You could get 50 different query plans.
They clean themselves up.
The question was, do they clean themselves up over time? And they only get cleaned out when you run out of the allocated space that you've stored for them. They get cleared out. They get the oldest ones, the most unused ones, get pushed out of memory. Or if you reset the database or the service, it clears all those out. So that's why when you restart a server, it seems kind of slower at first, and that's because it's doing a lot of stuff, but it's also has to recache all the plans that get ran. All right, so
Isn't there, from the guy showed on SQL Saturday, there's a way to tell the server to parameterize them? There's like something in the cache plan thing you can turn on with an SP configure or something that says, if these look similar, parameterize them and reuse that plan or something?
Yeah, there might be an option like that. I remember seeing something about how sometimes if you do have a simple enough query, it can kind of auto-parameterize it for you.
Yeah.
But it's
slower again. Right?
It's slower, and it's still using exec, which isn't as good as using the Execute Sql. And you're still opening yourself to SQL injection using exec and concatenation. So now we're going to run the same query, but we're going to put it inside of a stored procedure. And so we declare same user entered field values of 6 and 3. And we're going to call this store procedure, which passes in that 6 and 3 and does a select, the same select. But the results will change based on the value getting passed in. You can see that the results are the same as the previous example where we were concatenating on that value. Now we'll look at the cache plan again. We can see that there's only one plan in the system now because it passes in that parameter right there. So we can see it was used twice for the same object in the same plan. And that was because it's inside of a store procedure and naturally parameterized with how the store procedure was written. Yeah, another thing. Let's see. We'll turn on the query plan, actual execution. I want to show you something about store procedures. So we have the two execution plans. When this store procedure was created, the first time it was executed with a 6. And so this right here was executed with a 6. Let's look at the parameter list. Parameter compiled value is a 6. Parameter runtime value was a 6. So when we look at how it was ran, when it was ran with a 3, we can see that it was compiled with a 6, but ran with a 3. So depending on how your data is set up, or data has changed since it was compiled, you might get a very, very slow plan because it's going to look through, assume that the parameter is a 6 and kind of go with the, looking at the indexes, thinking that it's a 6, and, but actually run it with a 3. So if I dropped the store procedure and recreated it and ran it with a 3, then it would create the plan, assuming that parameter is a 3. And so that's called parameter sniffing. And the only way around that is to force a recompile with every run, which essentially rebuilds the plan every single time, which is not always a good thing to use. It's just something to be aware of and look into if you're not getting the right plan that you're expecting.
What's that? Yeah.
All right. So that brings us to SP Execute SQL. And with this, you can parameterize your Dynamic SQL. When you do it, you have to define, well, A, your query, B, the data type of each of the parameters you are using, and C, a comma separate list of the values that you're passing in for each of the parameters. And it's a prepared plan, so it will prepared with parameters, so we'll reuse the plan even if you change the parameter values. All right, so little tricky things here. So let's do with SP Execute SQL, you have your query first, and then your parameter definition and your parameters. But if you don't have any parameters, you can just run it without the parameters. And you have to have the query be an var car or in-car field. So now we can run it. Let's see here. So we can run it, and we get the results back. So this sample right here, I like to break it up with, well, 3 parameters: the query variable, the parameter definition variable, and then the actual parameters variable. Then we're going to parameterize the query we just ran, where we can change the quantity on hand. So we set the query to select star from the inventory table, enter join to categories, where the quantity on hand is less than the parameter we're going to pass in. The parameter definition is the comma separated list of the name of the parameter you are using and the data type. And then the parameter itself is 6. And then this is how you execute it. The first parameter is the query, the second is the definition, and the third is the list of parameters. So we can run that and we get it back. And then we use I can see in the system, in the cache plans, that we have the ad hoc one that we ran before and the prepared one that we just ran, where it's using the parameter. Sorry, this first one is not the query we ran before. It's this actual query going to look up the cache plans. So the system created an actual query plan for looking up query plans. So let's change. We can change the parameter value here, say 3, and we'll run it again. And then let's look at the query plans again. We can see that the prepared plan now has 2 use counts. So this helps mitigate against SQL injection. Because it won't allow you to pass in. If you try to say that, like that first example of your value and then a semicolon and then drop table, you'd have to pass it in as a string. And if you were looking for, where the category equals this string, it's not going to stop the string at food and then continue on running another SQL statement of drop table. It'll look for a category that says food drop table.
What does multiple parameters?
So what does multiple parameters look like? It would look like, let's see here, and C dot category title equals at title, and then we'll at title, let's say varchar 10, and then in here, let's see, let's run that. Error converting. And well, that's roughly what it looks like.
Okay.
So it's comma separated list. If you really want to get tricky and you have one or more optional parameters, I didn't have time to add this into the script. What you can do is dynamically build the query, and then dynamically build the parameter definition, and dynamically build the parameters, and then execute once at the very end. And that way you'll get an exact plan for whatever you're going to be querying on. You don't have to have one query where it's like, well, first parameter is either set or not set, and if it is set, run the where, and the second parameter, if it's not set, then 1 equals 1, or parameter and then table values.
So in the plan, it showed that it included the comment in one. Does that make two different plans, even with just comment differences?
So question was in here, it's the question was, does including comments and changing, if you change the comment or the spacing, would it create a different plan? And yeah, it does create a different plan.
Yeah.
Because you're running a chunk of code. So if you change that script, it's like, well, this is a different script. It'll show up separately in there. I had that when I was running it.
You would expect it would parse it into something canonical and save those or something, and not worry about spacing and tabs and returns. And that does go back to reuse the same exact text every time.
Yeah. If you have a query in production, it shouldn't, shouldn't be changing that much.
We thought the PHP side thing, though, did in the white space.